All right, section 11.5 is on the binomial theorem. Okay, so we're going to start out with a little bit of a warm-up here. So it says write the polynomials in standard form. So if you guys remember, we talked about multiplying polynomials in a previous chapter. So if I have a plus b squared, you can't just bring the squared in. You can't say it's a squared plus b squared. So what do we have to do? Yep, a plus b times a plus b, right? And then you have to FOIL it out. Okay, so we're going to go ahead and do that. So my first terms make a squared, my outer terms make ab, my inner terms are also ab, and my last term is b squared. So you get a squared plus 2ab plus b squared. So it wasn't just a squared plus b squared because we had a middle term. All right, now the next one is a plus b cubed. All right, so a plus b cubed is going to be a plus b times a plus b times a plus b. Okay, luckily we've already taken two of them multiplied by each other. That was the a squared plus 2ab plus b squared. That was the first part we did. Now we need to multiply by the third thing, a plus b. So you can't do all of them at once, right? You have to multiply two together and then combine the other ones. All right, do you guys remember how we multiply polynomials that look like this? No? Okay, so you take your a squared, and you're going to multiply it by everything in the second polynomial. So a squared times a gives you a cubed. A squared times b gives you a squared b. All right, and then we take our next term, 2ab, and we multiply it by everything in the second polynomial. So 2ab times a is 2a squared b. 2ab times b is 2ab squared. And then we take our b squared and we multiply by everything in the second. So b squared times a is ab squared. B squared times b is b cubed. Okay, it's pretty long. Remember, if you have 3 terms and 2 terms, when you multiply them together, you get 6 terms. So we have 6 terms before we combine. All right, now look for common factors. Or not common factors, look for common terms. So I have a squared b. Do I have anything else that has a squared b? Yeah, right next to it, right? So I have 1a squared b plus 2a squared b. So you get 3a squared b. So I have a cubed plus 3a squared b. Okay, then I look at the next term. I have ab squared. Do I have anything else that has ab squared? Yeah. So you have 2ab squared plus 1ab squared, so you get 3ab squared plus b cubed. Okay, so that took a little bit. So it gets even more annoying when you're asked to find something like a plus b to the 4th or a plus b to the 5th, right? So that would be, you'd have to multiply it out 5 times to get a plus b to the 5th. All right, so there is a pattern. So here's what a plus b to the 4th is going to be. So it's going to be a to the 4th plus 4a to the 3rd b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Okay, then a plus b to the 5th is going to be a to the 5th plus 5a to the 4th b plus 10 a to the 3rd b squared plus 10 a to the 2nd b cubed plus 5 a b to the 4th plus b to the 5th. Oops, I wrote 4th. 5th. All right, so let's look for some different patterns. So the first thing I want you to look at are the exponents. So for a plus b to the 4th, look at the a's. So look at the a terms. Do you guys see what happens to the a terms? Yeah, you have a to the 4th. The next term has a cubed, a squared, a, and then there's no a's. So it goes down. So 4, 3, 2, 1, 0. All right, what about the b's? they go up, right? So you have no b's in the first one, 1b, 2 b's, 3 b's, 4 b's. So 0, 1, 2, 3, 4. All right, same thing for the fifth. Do you guys notice a plus b to the fifth? Do you guys see the exponents? On the a's, you go 5, 4, 3, 2, 1, 0. On the b's, you go 0, 1, 2, 3, 4, 5. All right, so we at least know what's happening with the exponents. Also with the exponents, notice when you add for a particular term, when you add the exponents, see how this is a to the first, b to the third? What do the exponents always add up to be? Yeah, whatever your number was, whatever your power was, right? A plus b to the fourth, they're adding up to be 4. Okay, same thing for the fifth. It works the same way. So you have 5, 4 and 1, 3 and 2, 2 and 3, 1 and 4, 5. All right, so there's definitely patterns. Okay, but the weird thing is the numbers out front. You have 1, 4, 6, 4, 1. And then you have 1, 5, 10, 10, 5, 1. Okay, and there's not really anything that's like looking like a pattern when you see that. Because you're like, oh, well, in the first one you didn't have any, like you had a number in the middle. You had 6 in the middle. But in the second one, you have an even number of terms. So you have 2 10s in the middle. So what's up with that? So we use something called Pascal's triangle. So Blaise Pascal made this. Cool name, huh? All right, so there's a triangle of ones that you start out with. So 1, 1, 1. And the next row is going to be 1, 2, 1. The next row is 1, 3, 3, 1. Okay, what we are doing to get these rows is we are taking the 2 terms above a number and adding them together. So see how 1 and 2 add up to be 3? Okay, there's always ones down the down on the edges of the triangle. So we start out with 1 and end with 1 always. So if I take the 2 numbers above the next number I'm going to write, I have 1 and 3. So 1 and 3 add to be 4. Then I have 3 and 3. 3 and 3 add to be 6. 3 and 1, 4. So see how you're creating the triangle? So try to write the next 2 rows, see what you get. Okay, did you guys get 1, 5, 10, 10, 5, 1? And 1, 6, 15, 20, 15, 6, 1. All right, it gets big really fast. All right, so this next one is 1, 7, 21, 35. Right, we're always just adding the 2 numbers above it to get the actual number that we're on. So 35, 21, 7, 1. Right, it's going forever. We're going to stop at 7. All right, now it says each row of Pascal's triangle gives the coefficients of the corresponding binomial expansion. So for instance, the 7th row is going to give you the coefficients of a plus b to the 7th. So if I was doing a plus b to the 7th, I would write the numbers 1, 7, 21, 35, 35, 21, 7, 1. And then I would just take my a values and I'd go down. So I'd start with a to the 7th. Then I'd do a to the 6th, 5, 4, 3, 2, 1, no a's. And then I take my b values and I'd go up. So I'd say no b's, 1b, 2b's, 3b's, and so on. Does that make sense? So you'd be able to expand a plus b to the 7th pretty quickly. All right, so the only hard part about this is determining what a and b are. They're not always a and b. Like you don't always have a plus b to the 7th. You might have like 2m minus 3n raised to the 7th. Okay, so a and b could be something different. Also, the other weird thing about this is when I say the 7th row, I'm talking about this. So that means that this first row has to be what's called the 0 row. So it's the second one that's the first row. Okay, I always remember whatever the second number is, that's what row you're on. So 1, 5, 10, 10, 5, 1 would be the 5th row. All right, but that triangle is pretty easy to construct. You could easily construct that on a quiz or something. All right, so here's what I was saying. So a plus b to the first is 1. Or a plus b to the 0, I mean, is 1. a plus b to the first is a plus b. So notice how those coefficients are 1 and 1. So you have 1, 1, 1. A plus b squared, we said, was a squared plus 2ab plus 1. So it's 1a squared plus 2ab plus 1. So it's 1, 2, 1. The next one's 1, 3, 3, 1. So we're talking about the numbers out front. It's 1, 4, 6, 4, 1. And then the last one's 1, 5, 10, 10, 5, 1. Okay, so we're using Pascal's triangle to get those coefficients. Okay, so some people like to do these a little bit differently. So find each binomial expansion. So I'm going to show you 2 ways to do this. Okay, so if I have x plus 2y to the third, you could multiply that all out the long way if you want. That's fine. But if it was to the fifth, it'd be really annoying. All right, some people like to notice that it looks like a plus b to the third. They like to stick with the a plus b. If you have a plus b to the third, you know that you're going to have this row. You're going to have the 1, 3, 3, 1. So we write those down. We say 1, 3, 3, 1. A little bit more. Leave a little bit of room in between them. All right, and then they say, well, what about a's? If I had a plus b to the third, I'm going to start with a cubed, right? A to the third. So I have a cubed, a squared, a, and then the last thing has no a's. And if I have a plus b to the third, I'm going to start with b to the 0 and go up to the b to the third. So I have no b's in the first one, b to the first, b to the second, b to the third. You connect them all with plus signs. All right, so the expansion for a plus b to the third is just a cubed plus 3a squared b plus 3ab squared plus b cubed. So that's pretty easy to construct, right? You can find that pretty quickly. But what were the a and b values? So in your original, what's in the a spot? X, right? What's in the b spot? 2y. So now you go back through and you say, okay, well, x plus 2y cubed. All right, so I'm just replacing a with x, or b with 2y. So everywhere I have an a, I'm going to replace with x. Everywhere I have a b, I'm going to replace with 2y. Now make sure you're putting these things in parentheses. It will help you out a lot. So I have x is being cubed plus 3a squared, so x is being squared. B is 2y plus 3x 2y squared plus 2y cubed. So notice how the 2y is in parentheses. You're taking the whole thing and cubing it. And then you just simplify. So if you're simplifying, you get x cubed plus, notice how this is going to be 3x squared times 2y. We'll do it in the next step. This will be 3x times, what's 2y squared? So 2y in parentheses squared. 4y squared. Be careful, that's where people will usually mess up. Plus, and then what's 2y cubed? 8y cubed, right. So we get x cubed plus 6x squared y plus 12xy squared plus 8y cubed. So notice how we don't have those coefficients anymore. We don't have 1, 3, 3, 1 anymore. They've changed because we've been squaring something other than just a and b. The b was a 2y, so it's changing the numbers. All right, does this make sense? Do you guys understand kind of what we did? All right, so some people like to see the a and the b and go through that method. I personally I'm like, if I'm going to have to multiply this all out anyway, the way I do it is I just say, okay, if I have x plus 2y cubed, I know I'm going to have 1, 3, 3, 1. And I'm thinking, okay, well, the first thing is x, right? The a value is x. So I'm going to have x is being cubed, x is being squared, x is raised to the first, no x's. And then the next thing I have is 2y, right? That's like the b value. using quotes, b value. All right, so I'm going to have no b values on the first one. I'm going to have one b value on the next one. So 2y to the first, 2y squared, 2y cubed. So I just go from there. Notice how it ends up being exactly the same as what was here. Okay, so that's the way I do it. So I don't use the a and the b. I just skip ahead. So we're going to try that on the next one. All right, so we have k minus 5 to the fourth. All right, so you can go back to your Pascal's triangle. You can find what your coefficients for 4 are going to be. Or you can draw it off to the side. You can go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. It doesn't take long. So that means you're going to have 1, 4, 6, 4, 1 as your numbers. Give yourself lots of space. Okay, what's the a value? K, right? So you're going to take k and you're going to go start with the fourth power. So k to the fourth, k to the third, k to the second, k to the 1. And you don't have to put k in parentheses. I mean, it's just k is being raised to the fourth, right? There's no number there. So you can if you want though. So k to the fourth, k to the third, k squared, k. No k's on the last. All right, what's the b value? Negative 5, right? So make sure that b is a negative 5. So I have no b's in the first one. I have 1 b on the next one. I have 2 b's on the next one, 3 b's on the next one, and 4 b's on the last one. See how it gets hard if you don't leave enough room? It's all like smushed in together. Then I add each individual term together. Sometimes it's hard for you guys to see, but remember your 1, 4, 6, 4, 1. So they just go in front of those numbers. All right, now we need to simplify. So this is the hardest part, is actually simplifying this. So the first part's easy. It's just k to the fourth. The next part, you have 4k cubed times 1 negative 5, right? So just times negative 5. So what do you get? Negative 20k cubed, right? The next part is a little bit hard for people, so I go ahead and write it in 2 steps. So I say, okay, I'm going to have 6k squared times, what's negative 5 times negative 5? 25, right? So then I'm going to have 4k times, what's negative 5 times negative 5 times negative 5? Negative 125, right? Plus negative 5 times negative 5 times negative 5 times negative 5, so negative 5 to the fourth would be 625. So you should get k to the fourth minus 20k cubed. We have 6k squared times 25. Whenever I have 25s, I think of quarters. If I have 6 quarters, how much money do I have? Okay, you guys just don't use quarters anymore. You just use debit cards, right? Yeah, $1.50, so you get 150. K squared minus, so if you're doing 4 times negative 125, do negative 125 times 2, and then multiply by 2 again. So negative 250 times 2 again, so negative 500, K plus 625. That's your answer. Would it be what? Yeah, you can always check at the end. Notice how the K's go 4, 3, 2, 1. They should still do that. All right, you guys try number 3. So try it out. All right, so let's try it. So you start out with your numbers from the third row, so the 1, 3, 3, 1. All right, your A value is 6m, so you're going to have 6m to the third. Make sure it's in parentheses, so you raise the whole 6m. 6m squared, 6m to the first, and then no 6m's. All right, then your B value is negative 8. So you're going to have negative 8 no times, negative 8 1 time, negative 8 2 times, negative 8 3 times, Your pluses go in front of those 1, 3, 3, 1s. All right, so it's a little bit hard. You got some big numbers, I'm sure. So 6 cubed, right? 6m times 6m times 6m is going to be 216m cubed. Plus, let's do this one thing at a time. So I'm going to have 3 times 6m squared would be 36m squared times negative 8. The next one's going to be 3 times 6m, so 18m times negative 8 times negative 8, 64. And then we have negative 8 cubed. What did you guys get for negative 8 cubed? 512. Negative 512. So minus 512. All right, combined. So I get 216m cubed plus, so I need to do 3 times 36 times 8. Oh, times negative 8. So it's negative 864 m squared. Okay, then I have 18 times 64, which is 1152 m minus 512. Did anybody get it?
Close.
Close? You just messed up on one little thing?
Yeah.
Yeah. So make sure in the end you have m cubed, m squared, m, no n's, right? All right, let's try it again. So 2x minus 3y to the fifth. Do you guys want to try this one first? No, you just want me to do it? All right, so you can go back to your Pascal's triangle if you need to remember what your numbers are. They should be 1, 5, 10, 10, 5, 1. You can go ahead and put the pluses in front of the last 5 numbers. Okay, 2x is our a value. So 2x is being raised to the fifth, then 2x to the fourth, then 2x to the third, 2x squared, 2x, and then no 2x's. Negative 3y is your b value, so negative 3y, no times on the first one, 1 time on the next, 2 times on the next, and 3 times, 4 times, see I ran out of room, 5 times. You can always use 2 lines too if you need to. All right, so go slowly through it. 2x raised to the fifth. So 2x times 2x times 2x times 2x times 2x. You get 32x to the fifth. Plus, you're going to have that 5 still. 2x to the fourth is going to be 2 to the fourth, x to the fourth. So 2 to the fourth is 16. So 16x to the fourth times negative 3y still. Plus, you're going to have 10. 2y to the third is 8x, or 2x to the third is 8x cubed. Negative 3y squared is negative 3y times negative 3y. So 9y squared. Times. So then I have plus 10. 2x times 2x is 4x squared. Negative 3y times negative 3y times negative 3y is negative 27y cubed. I'm going to go to the next line. Plus, and my 5 times 2x times negative 3y to the fourth. What's that going to be? $81 y to the fourth. And then plus, well, minus, it will be negative 3 to the fifth is negative 243 y to the fifth. It's a hard one. Once you have those big powers, you usually get big numbers. Okay, so you get 32x to the fifth. Yeah, not done, are we? So you're going to have 5 times 16 times negative 3. So negative 240 x to the fourth y. Plus 8 times 9 times 10, so that's 720 x cubed y squared. negative 27 times 4 times 10, so negative 1080 x squared y cubed. 5 times 2 is 10 times 81, so 810. So plus 810 xy to the 4th minus 243 y to the 5th. That's your answer. It's annoying and time consuming, right? But not as time consuming as if you had actually had to multiply it out. That's crazy when you have to multiply it out. Don't do that. So learn this method. All right, so let's try the next one. So x plus 2 square root of x all raised to the 6th. Okay, so I'm going to have 1, 6. I forget this one. It's not one I use often. 1, 6, 15, 10, 15, 6, what? Or 20, I mean. 1, 6, 15, 20. Do another row. 15, 6, 1. Okay, so I have x, so x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x, no x's. And you have 2 root x, so 2 square root of x to the 1st, 2 square root of x to the 2nd, 2 square root of x to the 3rd, 2 square root of x to the 4th, 2 square root of x to the 5th, and 2 square root of x to the 6th. So you get x to the 6th plus, you're going to have 6 times 2, so 12, x to the 5th, and then you still have a square root of x. Plus, can you guys kind of do this next one in your head? So if you have 15, now if you had 2 square root of x squared, what's 2 square root of x squared? Close, not 2x, 4x, right? Because 2 is being squared as well. So you get 4x. So you're going to have 4x times 15 x to the 5th, or x to the 4th. So you get 60 x to the 5th. Right, the square root of x squared became an x times x to the 4th made x to the 5th. Plus, the next one, so you're going to have, this ends up being 8. What if you have square root of x to the 3rd? What does that become? Square root of x to the 3rd. It takes 2 square root of x's to get x, but then you have 1 extra. So it's x root x. Does that make sense? So you're going to have 8x root x there. So we're going to have 8 times 20 is going to be 160. I had x cubed and I have an x, so x to the 4th root x. Plus the next thing's going to be 16, right? 2 to the 4th is 16 times 15. So you're going to have 240. What about the x's? So you had x squared before, and then you have square root of x to the 4th. What's square root of x to the 4th? X squared, right? X squared. So x squared times x squared is x to the 4th. Do you guys see the pattern with the x's? So it went 6, x to the 5th, and an extra x. In other words, x to the 5 and 1/2. Do you guys remember square root is 1/2 power? And then it goes x to the 5th, and then 4.5, 4. It'll be 3.5, 3, and so on. Okay, so then plus 2 to the 5th is 32. So 2 to the 5th is 32. So I have 32 times 6. So 192. 192, I'm going to have x times whatever square root of x to the 5th is. So what's square root of x to the 5th? So each pair is going to become an x. What is it? It's x squared square root of x, right? So if I have x times x squared square root of x, x cubed square root of x. I would never do this to you on your test or homework, just so you know. All right, plus 2 to the 6th, 64. So you have 64 x to the 3rd, and that's it. Okay, and very quickly, let's talk about this pattern. When I taught at IU, they always had this kind of thing on the midterm or final, and they'd say, like, find the 18th term of, you know, this binomial raised to the 26th power. And so people would, like, literally write out the first 18 terms. It's like, no, there's a pattern. Like, you got to figure out the pattern. So basically, Pascal's triangle is going to be related to something that we call combinations. So if I'm talking about the 7th row and the first number in it, it's going to be 7, choose 0. We write it kind of weird. 7, choose 1. This will be 7, choose 2. And you can find these numbers on your calculator. Okay, so if I do 7, choose 2, like notice how it looks like a fraction, but there's no fraction bar. So if I do 7, choose 2 on your calculator, here's where you're going to hit. So get your calculator out. So hit 7, math, go over to PRB, 3, so it's NCR, and then hit 2. So it comes up as 7 NCR 2. So I read that 7, choose 2. So notice how that's 21. So that's how you get that term. Okay, so really quickly, if you wanted the 9th term, remember the first one's 7, or not 7, in this case it's 13 is your number. So the first one would be 13, choose 0. That's the first term. The second is 13, choose 1. So what would the 9th be? 13, choose what? What'd you say? 8. Does that make sense? It's always one less. All right, and then think about your x's. This would be x to the 13. This would be x to the 12. So this would be x to the, what number? You subtract the two numbers. So you do 13 minus 8. So whenever you have 13, choose 8. You do 13 minus 8. And then what's the negative 2y being raised to? What? So this was 5, right? 13 minus 8 is 5. So it would be 8. Yeah, the bottom number. It's raised to this number. All right, so then you can figure that out. So it's whatever 13 choose 8 is on your calculator, x to the 5th, whatever negative 2y is to the 8th. Okay, and I don't have that written down. So, all right, you guys need to go to class.